Hello and welcome to the midday keynote for Zadata Transform. I'm Maxi, VP of Business Development here at Zadata. And today I have the pleasure of introducing Kelsey Hightower, Distinguished Engineer from Google. Like many, my first introduction to Kelsey was through his really popular GitHub project called Kubernetes the Hard Way. If you're not familiar with this project, it's a tutorial that walks you through Kubernetes, using the difficult path. It's not the click that you get from vendors, it's sort of building it from scratch. And what's unique about it is it's really optimized for learning. So you take this long path, you learn, and it's been very popular. It's got about 12,000 forks, 35,000 stars. So pretty clear that, Kelsey's unique way of learning in the developer community and learning Kubernetes has really taken off. And then I guess the first time I heard Kelsey speak was back in 2019 at DevRelCon, which is a conference in San Francisco. My reaction was I was super impressed with his humility, his ability to take on complex topics and make them really digestible for the audience. And, looking forward to getting some of that today. So today I'm gonna hand it to Kelsey in here in just a second. He's gonna cover about 10 minutes on sort of edge computing and a quick introduction to WASM Edge. And then I'll be back to facilitate some questions. So please use the question and answer session or the question and answer feature, and we'll come back and answer some questions here in a few minutes. But with that, I'm going to go ahead and hand it over to Kelsey.
Hey, Maxi, thanks for having me. Look, I'm going to be talking about Edge mainly from the developer perspective. I think today we talked about all aspects of edge computing and where we're at and where we're going. But I want to kind of rewind the clock a little bit. When I think about Edge, especially as someone who works at a cloud provider, I think about the things that are closest to me, my Edge. And so if I think about the first time I interacted with a computer, it probably looked like this. In elementary school, we went to the library and we got computer time. And that is the closest that I've ever gotten to a computer at that point in time. And that machine, I was able to do everything. And I don't recall being able to get on the internet. So everything I needed was on that one machine. And then when I got my own computer and I wanted additional software, unlike today, our app store was actually this physical place you went through, like CompUSA. And so this is one of these ads that they used to send to your house, or you would pick it up in the weekly paper, and they would advertise like all these computers you could buy. And then also you can see the software you could get. And look how much software was back then, like $60 for a piece of software. None of us are used to that anymore. But this was the app store, literally brick and mortar. You had to go to it. And so if you wanted to write software, even for desktops that were starting to show up in people's homes, you had to have specialized tools to do it. And then you had to have a relationship with an actual brick and mortar store in order to distribute that software. So you had to go to a distributor, and that was not accessible to the average developer in the world. And so only a few companies got to actually build and ship software to the edge, the home, where people were using computing systems back then. And then, of course, over time, things would get democratized, where we get open source systems, the internet comes, and now we can ship software, not on CDs, but by giving people a download button. And so that's starting to broaden the playing field on who can actually write software and, more importantly, deliver it. And then I got my job in IT, and one of the things that I did in the early days was I used to do service calls. So that means going to businesses or to homes, and we would deal with these systems. And one of the systems that I remember dealing with was Bell and Howell mail sorting machine. So if you ever look at those envelopes that come in the mail, and you'll kind of see that little strip at the bottom, that means your mail was probably sorted by one of these machines. And they were super fast. They could do address lookups, even handwritten addresses way back then in the late 90s. They were doing these things. But the problem, though, was it needed an address database. That's right. Like if you needed to update a set of addresses, I remember I was called in like every week or every month to take the new set of address CDs or the address database and literally load it right there on the factory floor. I would have to wait until the business was closed. I would come in and I would get this address database that they sent on several CDs, and I would sit there and load them into this Windows NT machine, one at a time. And if you corrupted the database, then you had to start over. And so that became the edge in my mind. These closed off systems that were very close, again, to the problem, just like that personal computer in the home. And so again, this is pre-internet. I'm pretty sure the internet existed when these machines were around, but for sure, these machines were not connected. And if they were, you couldn't download these large address databases over the network. So instead, we actually had to bring those disks out. And if these things were ever to have a problem or there was a patch that needed to be installed, you got it. I had to drive out and actually service those machines on site. This would have been much easier if I was able to remote in and update these. So for me, this became a big part of the edge. And again, if you notice, that machine is hidden inside of this bigger machine. So it's just a small part of the engine, right? This kind of IoT space, we find computers in traffic lights, but we don't necessarily see them directly. And then just like in the other world, the only people who could actually build these are big manufacturers like Siemens and Bell and Howell. And if you wanted to write software for this ecosystem, then you would have to have a partnership with those vendors. Again, most of this stuff wasn't based on open protocols. And so you had to have those relationships if you ever wanted a chance to develop in those ecosystems. And then I got a job in the data center as a system administrator. One of the very first jobs I got was inside of a Google data center. They kind of look like this. This is a more modern one, but even the one I worked in about 16 years ago looked a little bit like this. And it was massive. I mean, every cable seemed like it was perfectly wired. It was the perfect length for the motherboard that it attached to. And at this point, we start to get the idea that there can be these kind of hyperscalers. And so instead of just delivering software from FTP servers or picking them up from the store, we could actually host a lot of this stuff centrally. The edge now, those home computers, they become more of these data planes, and these data centers, AKA the cloud, become the control planes. And boy, did everybody want to run and put their stuff into this central place because these data centers were faster. Depending on your workload, the data center could even be cheaper. But the other thing that was important about the data center was that it gave you the ability to get data out at much faster speeds that you can get from maybe a smaller colo or from a home office. And so we start to see this separation between the edge, the devices that are running factory floors, the things that sit in your home, or where the data is actually being served from. So the internet allows us to create some distance between those two. And like all things tend to come back full circle. Lots of things run to the cloud, and there's some drawbacks to that. Number one, we're putting computers in more places. We're putting computers in places that move, like cruise ships. And so in those situations, we're kind of back to a world where we may not have high-speed internet. And so we have to rethink this thing. Now, higher speed internet means the network isn't as much of a concern, but when all you have is a small cellular connection, you may not be willing to transfer all that data. So back to the factory floor mentality we go. We'll circle back on that one in a moment. But one thing that has happened along these transitions is the software and the hardware to manage all of these systems start to become commoditized. We're not just working with big vendors anymore. Even those big vendors are starting to use open source and open computing platforms in their own stacks. And then this happened. You guys remember that iPhone moment? Sure, we've all had mobile devices. We even had hints at mobile computers like the Palm Pilot. Some would consider the BlackBerry mobile computer, but not like this. This one had an app store built in. Even though it's not advertised heavily, this one was also based on a lot of open source software, like that web browser. It's based on WebKit. And a lot of things you could do with standard programming languages, whether it was C++ or Objective-C, you could actually take your existing desktop software skills and actually use them on mobile devices. And that's starting to open up the number of developers who can actually ship software to the new edge. The edge is now in your pocket. And there are hundreds and hundreds of millions of these devices, probably billions if you think about the average person's iPad, watch, and phone. So this is the new target for a lot of developers. And now most developers are able to transition from a data center centric world to this mobile world. And given that the App Store is built in and how open these protocols are, you can use standard tools, push them to one destination, and remember, there's still this latency issue. So it makes sense that maybe we push the native software to the device so it can run at full speed. And this is where we start to see the difference between like a native app, given that native experience. This isn't new. There's always been a lot of value of running the compute closer to the experience that you want. And I think the iPhone showed us that you can have the cloud be a delivery mechanism for the software. You can even have the cloud be where the APIs and the data is derived. But there's still some value in having a native interface that runs directly on the device that gives people the super fast experience while you're dealing with the data in the background. So this is the marriage of both of these worlds. We don't really think about this as edge computing, but I think it's one of the best examples of edge computing. The device becomes the data plane and the place that the experience occurs, and the cloud can be used for things like synchronizing data, contacts between multiple devices. And even better, if you lose your phone, typically you log into your account and all the settings and data comes back. Now, there's another movement that happens around the same time. When the iPhone was introduced, 4 or 5 years later, we get the Raspberry Pi. And look, you could have always built your own devices using a small Linux server, maybe even a small embedded computer. But look, those things used to cost a ton of cash. And most people didn't have access to the hardware. And then we get this Raspberry Pi. And notice what they did. They took industry standards like USB, HDMI, SD cards, and shrunk it way down and made it affordable. I mean, the first Raspberry Pi that I was able to purchase was $35. And it had all of these accessories. Now, the thing that's super important about this component is that now we're moving into a world where you can have even commodity hardware. And look, the chip inside of that Raspberry Pi is much faster than that chip that was in those original PCs that I used to use coming up. So now the power's there. And these things are shrinking down so far that they're suitable for the edge, the thing that powers the grocery stores, the thing that powers that moving ship. Or if you shrink it down even further, those things that go into maybe those TVs and those microwaves, we're starting to get to a point now where even the hardware has been commoditized, the interfaces are standardized, and there's a much shorter gap between industry solutions like RFID, USB-C, and Bluetooth. These things are also finding their way in consumer electronics. And guess what? On the developer side, we already have the right SDKs and library frameworks to interact with all of this software. So if you want to write software that targets one of these devices, it's probably pretty straightforward nowadays. But what about those enterprise applications where you need to deploy millions of these devices and actually manage them? Where I think Android and iOS have done a good job on the phone space, we don't quite have that cohesive interface to this world. And so what do we have to do? Well, one thing we did was look at the other side of the house, which is developers had already started moving to some industry standards themselves. Now, maybe throughout the day, you heard about containers. Look, there's a lot of complexity that can be talked about when you try to describe containers. But the way I like to think about containers, it's a way of abstracting away all the things that come into a software system. When I think about the IoT world, I remember getting my first IoT device, and I was amazed at how it worked. It shipped with an operating system. It had a serial number. It had an SSL certificate, and it had a configuration that was already ready to go so that it can call back home. In many ways, a lot of those IoT devices were like a container for hardware. Everything you needed to deploy that thing, sometimes as easy as plugging it up to a PoE enabled Ethernet cable, and it would just power on and be ready to go. The other side of the house, Docker containers, are a similar tactic, but for software. Now, instead of talking about Python versus Ruby versus Java, we have a much better way of thinking about our software and putting that in the same container space that our hardware was in. So what happens when you combine the two? Well, if I have an IoT device that's ready to go, instead of just having a basic operating system like Linux, we need a runtime. Now, this is where things start to get a little interesting. We need a runtime that doesn't force people to think about all the low-level details. Look, nothing wrong with Linux. You can definitely SSH. You can install configuration management tools. I used to work at Puppet Labs, and I know a lot of people who went that route. They installed a bunch of agents on these devices. And look, even though these devices have gotten really, really powerful, you still do not want to have desktop class software or hardware in every environment in which you deploy. So CPU and memory still come at a premium. So we want to collapse those layers. And one attempt at doing so was this thing called Docker. And I'm pretty sure a lot of you have heard of it already. But the idea is that we would have a runtime that would attempt to abstract away the underlying operating system and give us a mechanism for making these updates. Now, the first time I saw something like this in action when I was in the networking space, I remember when I was a network administrator, in order to manage a network switch. Now, look, when you rack a network switch or router, you ain't moving that thing. It gets all wired up and it's mounted in its rack. The last thing you want to do is have to unplug anything to do any maintenance. And sure, you can do redundancy, but once it's filled, deployed, you kind of want to leave it there. And so we need updates to be atomic. And to think about what that means is, if I'm going to update my networking gear's operating system or settings, I need this magical trick that I can do where I can have one partition running the current version and have a standby partition where I can install the new version and do a cutover. And if it doesn't work, I need to be able to go back. That's that atomic updates. And you saw this at the hardware operating system level. We've seen that for a couple of decades. Docker does something similar for our software. So now we can roll out software in an atomic way. So now our software stack is starting to match the capabilities of our hardware and operating system stack. But let me be honest with you, Docker isn't enough. It's a beautiful runtime, especially in these edge deployments, but you don't have something key, which is orchestration. Imagine installing these small devices with just Docker alone in 10,000 stores. You do not want to write SSH for loops to try to run Docker commands across them. You need some orchestration. And honestly, how do you know when things aren't working? You probably want to do what we do in the mobile space. Even though the edge is where the data lives, and maybe that's the core of the experience, we need to push some of the data and analytics and maybe even logs back to a central place so we can use it to drive other systems. And then that's when you're introduced to the CNCF landscape. Oh my God. Your Raspberry Pi is no match for this chart. There is no way you're installing all of this stuff on a Raspberry Pi or probably any edge device. Yes, it's true. Sometimes we are running server style hardware on the edge, but that's not always the case. And again, it comes at a premium. And so when you look at all of these pieces, it reminds me of when I logged into a Linux server for the first time. I saw grep, sed, awk, bash, all kind of utilities to make that server do what I wanted it to do. But just like the transition from that world to a runtime that was purpose-built for running apps, we need to do something with all of these pieces. Sure, we want logging on the edge. Sure, we want observability on the edge. Security is also a big thing, and now it's becoming a bigger part of the secure supply chain. We need to know where that hardware comes from, and more importantly, we need to know where the software that runs on top of it comes from. And so we have this collection of processes. Now we have another challenge in the industry. It's 2023. It took a while to shrink down data center hardware to the point where we can run it on the edge. Look, we now have things like TLS offloading, SSL offloading, and chips that are suitable to run on the edge. I don't think we're quite there yet on the software side. It's the early innings. How do we shrink the best of breed software that's suitable for the edge? I think that work has already started. There are many members that are working on this problem, trying to take cloud native software some of those beautiful patterns that we have around containerization and some of the industry standards for doing things like observability. And if we can build a new operating system, some of you may be familiar with tools like Eve OS, this idea that we can shrink down these components and have them baked in by default, nothing to install. Now that thing that we ship around, that hardware to the edge, it will finally have an operating system that's suitable for this style of deployment and software development that we're used to in these other environments. In many cases, it's exactly the same runtimes, Docker, Kubernetes, et cetera, that we have out in the cloud. And I got a feeling if we manage to pull this off, just like that transition from the Apple desktop to the iPhone, imagine the number of existing developers that will be able to use existing skills and techniques to start to innovate on the edge and even manage it. There's another hurdle left, which is the App Store model. How do we take the edge and turn it into the same easy to deploy platform that you see in iOS and Android? Well, there's going to be plenty of opportunity with that App Store software delivery model as well. And I'm pretty sure you all have a ton of questions around this transaction that we've been on and the trajectory that we're going. So to help me dig into those details, I'm going to welcome Maxie to the stage. Welcome back, Maxie.
Right on. Thank you. Great job, Kelsey. So yeah, let's dive into it. You talked a little bit about sort of the history and how things have progressed, and like someone coming into this for the first time, maybe from the IoT side of the house or something like that. You look at this spectrum, you have VMs and containers and that eye chart of the CNCF Kubernetes landscape, things like WASM that are brand new, like what do you recommend for a developer? Like, do they jump to the latest thing? Do they follow the progression the industry's taken over the 20 years? Like, how do you deal with sort of, technology time travel from a developer's perspective?
Well, I mean, look, as a developer, I like to ask myself what the fundamentals are. For example, if someone's going to ask you to develop for the edge, the first thing you want to ask is like, what capabilities do I have? And what frameworks can I leverage? Like, for example, if I'm going to write an HTTP web service, I'm not going to start by writing my own HTTP library. That makes no sense. So if you're new to edge computing or you're coming from the IoT space, I think you got to look at these frameworks, because even in the IoT space, we're asking people not to just use these standard IoT protocols. A lot of people are used to like those very tiny messages. Now we're saying, hey, let's just use gRPC at the edge. And you're like, what is gRPC? Well, now we have the ability to start communicating with the same protocols and the same libraries as before. So look, fundamentally, we're making connections. I remember, and I'm pretty sure it's still the case, there are a lot of people who made the wrong trade-off, or probably the right trade-off for the time. Security is an afterthought in some of those environments. Like TLS, what's that? Why would I want a secure connection from my toaster to the cloud? Well, there could be some problems if I can use your toaster to get on the rest of your network. That's an issue. So I think what we can do is find common fundamentals. What we're seeing now is software development isn't so specialized anymore. It doesn't have to be. So you can use similar frameworks for embedded programming, if that's still a thing, because now I think instead of burning things into chips, we want to be able to upgrade software over time. And that means having systems that allow us to do that. And so I would suggest this: if you're coming from the IoT world, play around with Docker, maybe get a little Raspberry Pi, install Docker on it, and learn that new workflow. Very different. I remember programming for an IoT device. It was like plug in this USB thing and then use this tool that would then like transfer the software through this kind of proprietary thing. I'm like, what is this? The Docker world is a little different. So kick the tires and see what you can do with it.
Cool. Yeah, I like that approach. And, Raspberry Pi is super cheap. So great way to get started. Let's see, one from, I guess, the audience. Maybe off topic, but the question is like, are you still on the hook to do technical support for your family? And if you're not, like, how did you get out of that? Because I think everybody on this webinar is in that same boat.
You know what? I would probably say this, the biggest tech support issue you used to get back in the day was like, my Wi-Fi isn't working or something like that. And I'll tell you, a lot of those devices have gotten way more user-friendly. You plug them in, there's some partner app that will debug and troubleshoot, set up a strong password and give you very easy tools to share it. But what I tell people is that I know nothing about computers anymore at all. If you have a programming language problem, no problem. the work I do is in the cloud. So you're better off calling someone else. And hey, much respect to the people who are still really good at that stuff, but I don't do IT support. I even got one of those t-shirts for the holidays. I can't fix your computer. I work at Google. You should try to use it too.
Yeah, I end up setting the clock on pretty much everything in my mom's house every time I visit. Cool. So let's see, another one from the audience. How will edge computing affect, it says normal people, but I guess maybe everyday lives is maybe an extension of that. Like, how do you think about edge computing and today, like, where is it showing up, and, how do you think it'll affect people's outcomes going forward?
Before I answer that question, I'm going to answer the other one more step. I
Yeah.
remember my wife came home from work one day and she logged onto her computer and she was like, "What's this?" I was like, "Babe, that's Linux." She was like, huh? So where's my stuff? I was like, "Don't worry about Microsoft Office. Open Office is basically the same. It's basically the same thing, right? Here's how you write Word docs." And so she tried to import an Excel spreadsheet with all these custom formulas and it didn't work. She was like, "Hey, I really need my Windows back." But though it did teach her, she tried it for a while. And she started to understand that these interfaces are roughly the same. There's some nuances there. And whenever someone would ask for help, I used to give them one advice. I want you to look to the top. I want you to scan left and right. And I want you to click on all the things you think could help you before you ask me. I don't mind helping you, but I at least want you to at least try a few things, click on a few things. And then if you do that and you ask me for help, no worries. And then I always took the opportunity to train them on how to debug. So when my daughter wanted to learn or play the Nintendo Switch, I was like, "I got you a Nintendo Switch, but you got to hook it up." All right. And so she's going through the instructions, like, where do these cables go? And I would explain to her which each of those cables were. So they have been trained that they got to read the docs first. They got to try a few things, restart it twice. Then you can ask me. And then I'm going to teach you at that point in time to fill in the knowledge gap. So that was my way of doing it.
Nintendo Switch the hard way.
Yeah, Nintendo Switch the hard way. The other question around the edge, honestly, there's a couple of things. I think in the cloud world, there was this idea that everything would move to the cloud. I remember people ran around saying that. And I think people got a dose of reality, this thing called latency and why it matters. Like when you go to a hospital or you're dealing with critical systems, you can never, ever have the network introduce a failure. Imagine flying in a plane and the control system needed a constant connection to the cloud in order to work well. You ain't going for that. You ain't trying to hear that. And so I think the cloud actually showed people how important latency actually is. And so in that case, they're just starting from the cloud, from the perspective that I'm coming from, you start to see the advance of the CDN. And you have companies like Cloudflare and Fastly who go out and start to develop the edge. And I think a lot of people grew a lot of respect for companies like Netflix that was born in the cloud, but quickly realized that you got to get this movies and videos closer to the customer. And that means investing in the edge, the thing outside of the cloud. And so I think a lot of times, if you want to have a perfect experience or really great experience, latency matters in all of those things. Now, and one analogy that may help people with this is that think about pre-airline industry. Think about the days where it takes 9 months to go from one country to the next. When it takes 9 months to go between countries, there is no such thing as vacation. You can't stay 3 days after taking 9 months to get there. If it takes 9 months to get there, you live there now, right? You've moved permanently. But when you start to have a situation where it's a 5-hour flight, now it makes sense to have a vacation where you can just be there for 3 days. And so that's what I mean by closing that latency. And so when you close latency, you can have a different experience. And so I think a lot of people don't realize that how important that experience is. So that's why I'm a big believer that, edge is going to be around for a long time. Some people used to say on-prem, look, if you want to be cool, let's say you missed the boat on cloud, you don't have to call it on-prem, just call it edge. And you're going to be looking real good on LinkedIn right now.
Yeah, but I think we're running out of time. But just to comment on that, I think edge and cloud are connected. We have a session coming up later today that sort of debates that actual topic. But we have run out of time. We have a bunch of questions. This has been awesome, Kelsey. Really appreciate the time and perspective. We're going to take a short break. Let's see, the next session start at 12:15 Pacific, so about a 15-minute break. We're going to break into the business and technical tracks again. And on the business side, we have real world deployments. So we're talking about practitioners that, have made it through that gate and got to production. And then on the technical side, it's kind of that point I was just talking about. Does the edge require cloud? And a sort of a deep discussion around that. But again, Kelsey, great stuff. Really appreciate it. Thank you very much. And everybody enjoy the rest of the day and the rest of the conference. Thank you.